Welcome, good morning, good afternoon, and good evening. This is Dr. Samuela Guida from the International Water Association, and welcome to this fifth day of the PrimeWater Multi-User Panel Stakeholder Week. The focus of today is amenity, recreation, and aquaculture. So while we're waiting for the last people to join, I would like to give you some housekeeping rules. So if possible, please rename yourself with your name and your company. And do feel free to introduce yourself in the chat, your name, your company, where are you calling from. And please note the meeting will be recorded and posted on our YouTube channel. So if you have any concern about this, please do send me a message. And if you wish, you can show your video, but please mute yourself if you're not speaking. And for each presentation, please add your question in the chat box, which you find just below. And if possible, do indicate the person you are addressing. And note that after the meeting, you will receive the slides and the recording of today. So as I was saying, this is the PrimeWater Multi-User Panel Stakeholder Week. So what is the multi-user panel? You hear more about PrimeWater later, but we have a group of international experts who provide feedback on the Earth observation enabled services developed or extended in the context of the PrimeWater project, but also they participate in the co-generation process itself through a dialogue like the one we are having today. We had the first MUP workshop in October 2020 last year, and in that we gather initial feedback on what different users think about different services. And this year, the second MUP was organized as a Stakeholders Week. So we started on Monday with a session on water resource management. Then we talked on Tuesday about disaster risk management, then potable water. Yesterday, we had a very interesting session on energy, and today is the amenity, recreation, and aquaculture. So the main objective of this week has been to provide an overview and update on the services that PrimeWater can offer to you, and to understand how different sectors are using Earth observation services to address issues such as extreme hydrological events or harmful algal bloom, and also to discuss the added value of the PrimeWater products when addressing these issues. So today we have a really packed agenda. We will start in the first session with a bit of an introduction about PrimeWater. Then we will have a moderated discussion with our really amazing panelists. And for that, we will use a group map activity. So please monitor the chat because all the links will be there. And finally, we will finish with the PrimeWater survey on Earth observation services and how to assess behavioral attributes for adopting those. So just a little icebreaker poll to get to know each other. So you'll see on your screen two different questions. One is about your sector, and one is about if you use Earth observation technologies in your work. So you should be able to see those, and I'll show the result in a minute. So you should see the result on your screen. So it looks like the majority of you comes from consultancy, then government organization. There is also 7% of you comes from other, and do let us know in the chat what that other is. And then NGOs. And if you use Earth observation technologies in your work, looks like the majority of you does use it directly. Oh, perfect. Thank you all so much for that. And I'll now leave the floor to Dr. Eva Maria Haas, who will set the scene for today. So Eva, the floor is yours.
Thank you, Samuela. Thank you for the nice introduction. And maybe to start, actually 21%, my aim is to excite everybody that is here, but to really convince the 21% that are not using Earth observation yet to do so in the, I would say, near future. My name is Eva Haas of EOMAP. I'm head of strategic accounts. And I'm also the first marine Earth observation evangelist. And for the ones who do not know, the word evangelist comes from Greek, and it means bringing the good news. And I believe there are many good news and ideas that can be brought when it comes to intelligent water services for amenity, recreation, and also aquaculture. So let me, sorry. Navigation problem. Well, the first good news is that in Europe, we have excellent bathing water. The European Environment Agency mentioned in the report for 2020 that the European bathing water quality remains high, and the minimum water quality standards were met at 93% of all the sites. If you scroll down in that article, you find a small sentence that mentions that the quality of a number of bathing waters could not be classified due to the inadequate number of samples in relation to the restrictions that are caused by the epidemic. And here we go. This is exactly where our satellites come into play. And I can recommend a case study from the European Association of Remote Sensing Companies, ERSC, to you. It's a good reading, and it shows how satellite data can really benefit and complement the traditional means for lake water quality management in Germany in this case. So the other part, as I'm talking about the bathing water on one hand, but we also want to look at aquaculture. And also here there are some, I would say, interesting news. Fisheries and aquaculture, the sector has significantly expanded in the past decades, and also trade and consumption reached an all-time record in 2018. The Food and Agriculture Organization mentions more than 500% rise in global aquaculture production compared to the 14% of the traditional fisheries. So I think this is quite remarkable, and we see that this sector is really in need of adequate information to also work sustainably. So what are the challenges that the sector that we're looking at today is facing? Well, they both have in common that the freshwater and also the marine hub toxins can have a broad range of negative impacts on aquatic ecosystems. We see in terms for aquaculture, we see that the high biomass blooms can cause low oxygen events, and that can then kill the fish. Furthermore, if the sunlight cannot penetrate through the water, it prevents the growth of other algae and also thereby disrupts the food web. So this results in actually major economic losses for this aquaculture industry. On the other hand, the amenity services and recreation, they can be severely impacted, as you can all imagine, by extreme water quality events. Here, public health is at stake, and also the economic losses are very high for this industry. So what is needed? Advanced water quality monitoring is needed. And we asked in our first stakeholder discussion, what are the major indicators of concern? Because what we would like to do is really understand what are the requirements of our users and the customers. So water quality elements such as chlorophyll, temperature, turbidity, dissolved oxygen, and also hub indicators are required. Then also reservoir lake mixing and stratification indices are needed, as well as information about currents. So our solution that we offer in the PrimeWater approach is that we provide valuable information about critical water quality parameters to, on one hand, accelerate the operation decisions and also have better information compared to the current standard, probably very good monitoring approaches. And this is particularly true for aquaculture. We want to assure supply stability. Let's have a quick look to the overall setting of PrimeWater. We're working not only with Earth observation, there are experts also present that have the hydrological modeling capabilities and also data assimilation. And together we are able to generate real-time, short to medium range water quality and quantity forecasts for reservoirs. This is all then presented in a very nice way. So if you don't want, you do not have to dive deep into our data, but you can receive it via the operational PrimeWater platform, where you can really get water forecasts as a service. This is also maps, but also beyond in terms of statistical information, which comes quite handy if you do not have much time. So I'm not going much deeper in here, but really worthwhile visiting and having a look yourself. I'm coming from the Earth observation world, and that's why I'm talking today specifically about the operational Earth observation data delivery. You see on the left-hand side a schema of the EO-based water quality calculation, and all the parameters that I mentioned before can readily be detected with Earth observation data. So we are taking, let's say we can do near real-time observations, and I just repeat it again. It's important to know that we can look at water quality in terms of turbidity, chlorophyll A, the surface water temperature, and also the suspended matter. At EOMAP, we're using the approach that we look at all the components. We have sensor parameters, we look at the atmosphere, and we also use optical models to look for the specific properties to arrive at the best water quality parameters. And of course, always have a quality control here. The beauty is that our physics-based approach is really working globally. It can be harmonized over different water bodies globally. So we are working in any kind of setting. Then there are also no dependencies on local survey data. It's nice to have, but it's not a must. And also it's very interesting that we can work sensor agnostic. So out of the fleet of available sensors that are useful for water quality monitoring, we can choose the ones that we find best suited for us. For the PrimeWater use cases, there is one in Italy, in Sardinia, that is important for the topic that I'm talking about today, and also Australia, Legume, and in the USA, Lake Harsha. We are using Sentinel-2 and also Landsat-8. Sentinel-2 products arrive at 10-meter spatial resolution, while the Landsat-8 data comes at 30-meter spatial resolution. So let's have a closer look to our case study in Lake Harsha. Well, we are here in the USA, and it's a large reservoir that is managed on one hand as a source of drinking water by the Ohio Environmental Protection Agency, and also it is important for recreation and managed by the Department for Natural Resources. So it's really a multifunctional water body, I would say. You see on the left-hand side here, the water body as it is in the two-color image. And we have, of course, analyzed the data. And here you see the surface temperature at a certain virtual station for the past 3 years, which is important to understand also time series in terms of the climatic changes that are ongoing. So this was the example from Lake Harsha, and let me jump now. This is the most fast you can travel between continents. We're now going to Australia, and here we look at Legume. It's a major reservoir on the Murray River, and it's designed for flood mitigation, hydropower generation, irrigation, water supply, conservation, and also recreation. So algal blooms have become very frequent here, and I think it's quite shocking that with 5 mega blooms in the past 13 years compared to 4 in the past or preceding 65 years. So there's definitely some work to be done on the water quality here. And they also have a lot of issues because Legume has been identified as a source of the cyanobacteria in the Murray River that comes then downstream. So this is what we're working on. As a conclusion, and maybe also an appetizer for the 21%, we can identify the spatial and seasonal trends reliably. We can support aquaculture, amenity, and recreation by providing easy, accessible, and intelligent information. Don't be afraid to get hands-on Earth observation data products. And the beauty here in PrimeWater is that we assimilate it with modeling results and thereby can also look into, let's say, the future a bit, because normally Earth observation is, of course, looking at the current data. So I would like to thank you. Of course, this is not only done by EOMAP, it's a large consortium, the PrimeWater team. And I would also like to take the opportunity to highlight the FIRE, the European Forum for Earth Observation. If you're interested to see how Earth observation can help in various applications, not only in the marine and water sector, please visit. And yeah, here, don't predict the future, choose it. Thank you for your attention. I hope the scene is set and I wish us a very interesting discussion now and yeah, diving a bit deeper into that topic. Thank you.
Thank you so much, Eva. And if you have any question, please do not hesitate to ask them and write them in the chat. We now move to the second presentation. So Eva has talked, as mentioned, the PrimeWater operational platform, and Evangelos from MBIS will give us a bit more of an overview of how the platform works. So you should be able to see the presentation now.
Hello, I'm Vangelis Romas from MBIS, and I'm going to make a short presentation of PrimeWater's operational platform. The platform is available through a web browser, either through the PrimeWater's website or directly through the second link. This is the initial page of the platform with the 4 operational case studies of PrimeWater in Europe, United States and Australia. The PrimeWater currently offers 4 services, which are the EO-based monitoring system, the Hydrological Forecasting service, and the Water Quality Forecasting service, which is offered both by process-based and data-driven models. I will now jump to Melbourne Western Water Treatment Plant, and I will start with the EO monitoring service, which provides operational EO-based water quality products from Landsat and Sentinel missions. On the map here, we are able to see the latest available satellite image for our case study, which is for today, obtained just a few hours ago. The product shown here is chlorophyll A concentration at a resolution of 10 by 10 square meters. And by clicking on the map, we can read chlorophyll concentration at various points of interest. You may notice a gap here in the center of the map, which, as you can see in the true color image, is due to the cloud coverage. Apart from chlorophyll A, we are also able to quantify turbidity, total suspended matter, total absorption, shaking disk depth, and also a harmful algae bloom indicator, which classifies the probability of hub existence based on the presence of phycokianine pigments. Also, we are able to provide surface water temperature from Landsat. However, this product is not available in this case study due to the low resolution of Landsat at 30 by 30 square meters and the small size of the ponds, which causes a strong interference with the land boundary. However, surface water temperature is available on all the other case studies. In the calendar here, we can see the dates with available overpasses of satellites, and we can go back in time until 2015. Also, there is a useful tool for exploring the temporal variation of a parameter in a selected area. For example, in the graph here, we can see the historical turbidity values for the last 3 years at the selected point of interest. Currently, these EO-based water quality products are produced by EOMAP's processing algorithms. We also aspire to include algorithms from other remote sensing partners of PrimeWater, for example, CSIRO's processing algorithms. And we also aspire to include hyperspectral water quality products from Prisma and DESIS missions, although these products will not be available operationally, but only for historical periods. The next functionality of the platform is the Hydrological Forecasting service. I will now jump to Legume and select the Hydrology tab. This service is provided by SMHI and the worldwide HYPE model setup. In the map, we can see Legume and all its upstream hydrological catchments, These two contribute directly in the lake, and if I click in one of them, I can view the hydrological forecast for 10 days ahead regarding river discharges entering the reservoir. In the graph here, we can see hintcast and forecasted values of river discharge for today and the following 10 days. Apart from river discharges, the hydrological model provides also forecasts of nutrients, nitrogen and phosphorus, and suspended sediments. And those variables are a very important input for the water quality modeling that is performed inside the reservoir. The hydrological model offers both a deterministic and probabilistic short-term forecast. If I switch to the probabilistic forecast, then we still have 10 days forecast, but this time we simulate a hydrological ensemble of 51 individual model trajectories, as you may see in the graph. So apart from the average ensemble value, we can have an estimation of possible range of values for each day, and we can calculate some useful statistics such as percentiles, which is a valuable input for quantifying and dealing with forecast uncertainty. There is also a third hydrological setup, which is available only in the European case study, which is a seasonal hydrological forecast, where we can have forecasts for up to 7 months ahead, averaged on a weekly basis. Moving further down to the modeling chain, we have reservoir water quality forecasting provided by Envis. This is the Moulargia reservoir in Sardinia, where we have used the Del 3D suite to set up a three-dimensional hydrodynamic model coupled to an ecological model. The hydrodynamic model is forced with meteorological and hydrological input and provides us the circulation pattern inside the reservoir and water temperature for the next 7 days. The map currently displays water temperature for the top layer on a grid of 100 by 100 square meters and 20 vertical layers. By clicking on the map, we can read temperatures at each cell. We can also visualize the water velocities with these nice animated arrow traces. And of course, I can move this time slider up to 7 days ahead in the future in 6 hours intervals. Actually, there is a nice tool that visualizes the evolution of the parameter in the forecasting period. For example, in the graph, we are now observing the diurnal variation of temperature in the topmost layer. As I said, we are using a three-dimensional model, so apart from the top layer, we are also able to get information for any depth we would like. For example, here, in the middle layer of the reservoir, the temperature variation is not so pronounced. Values are almost identical for the forecasting period. The vertical profile of each forecasted parameter can also be viewed in a separate graph for any selected point. For example, here the model indicates that there is a thermal stratification at the selected point of the reservoir. The parameters of the water quality model include chlorophyll A, nutrients, phosphorus and nitrogen, suspended sediment and dissolved oxygen. Here I have selected chlorophyll A, and the map and the graphs are now showing chlorophyll concentration. And finally, there is a third tool that allows us to view cross-section of any simulated parameter along the two main directions of the reservoir. Both in the hydrodynamic and water quality models, we are incorporating data simulation techniques that are using satellite-based products as well as in situ measurements to correct the model state and avoid error accumulation. So with the process-based models, we are able to expand the available information that we have for our reservoirs up to 7 days ahead in the future. And compared to the Earth observation, we can also have information at deeper layers and information about non-optically active parameters like nutrients. Apart from the process-based models, Envis is also employing machine learning models for forecasting chlorophyll and algae bloom events. So I will now move to our last case study, which is Lake Harsha. Data-driven models are trained for specific areas of interest presented as triangles in the map. Using meteorological forcing, forecasted nutrient fluxes from the hydrological model and are compared against EO-based chlorophyll values or even in situ measurements, since in Lake Harsha we had some nice historical time series with a large number of chlorophyll values and cyanobacteria cell counts. We are currently using 3 types of machine learning algorithms: Gaussian process regression, random forest, and random undersampling boosting. I will stay in the GPR model, which predicts chlorophyll A concentration only in the surface layer this time. By clicking on a point of interest, we are able to read the chlorophyll values at the current time step. Again, there is a graph that presents the time variation of the forecasted parameter. The dashed line are the hindcasted values, the continuous line are the chlorophyll values for today and the next 10 days ahead. One nice feature of the machine learning algorithms is that they can provide us with some confidence levels. So for an 80% confidence level, we can see that the predicted values of chlorophyll A concentration increase from 4 micrograms per liter to almost 20, and even higher for the 90% confidence interval. I will now jump to the random undersampling boosting algorithm to present you a different type of product we are using for bloom forecasting. So this algorithm has been trained to predict cyanobacteria cell counts, but not as a scalar quantity, but as a probability of exceedance of a specific threshold specified by WHO. And we have made this choice because we have seen that the model has a stronger skill in predicting if cyanobacteria concentration are going to be over or under the threshold of 100,000 cells per ml, rather than in quantifying exact values of cell densities. So in the graph we can see that the model predicts that for the selected point of interest and the entire forecasting over a horizon of 10 days, we're having a no-hub situation with a high confidence level. While if I click to this point, then we see that we still have a no-hub situation, but this time with a lower model confidence.
Perfect. Thank you so much, Evangelos. I'll open the floor for some questions. And as I was saying, please feel free to add them in the chat. Or if you want to unmute yourself, please feel free to do that as well. Okay, so I have some questions, and maybe I can start. So Eva, can I ask you to switch on your video?
Sorry, it takes a moment. Yes, I'm here.
No problem. Okay, so I have a first question for you, which is it possible to go to even higher resolution for the water quality applications?
Yes, good question. And I'm referring to the slide that I have shown with a multitude of sensors. I can say definitely yes, we can go to higher resolutions. We are using commercial satellite data for that. So mostly it's a world view or planet. With this, we can reach a several times daily, let's say, coverage in terms of the temporal observation. And we can go to 2 meters in spatial resolution. It all has to be considered as the cost benefit. Let's say you have to think this is a commercial data. Is it worth for your application to pay for the satellite data, this certain amount on top? Then yes, if your application is worth that and the cost benefit is there, technically it's absolutely possible and implemented because we're working with a sensor agnostic approach.
Thank you. And I see there is one question in the chat. So can Earth observation be used for underground water?
No. So yeah, no and yes. I mean, this is a bit out of the water quality topic. I know that, but that's another topic. You can use lineament, so you can look at geological features and look then for groundwater. But what we are doing is really to look at existing surface water and here look at the water quality. And I see there is this other question, how Earth observation is used. It is the schema that I showed before. We're using optical sensors, then physics-based models. that are rather complex. I think I can't explain all the details today, but invite you, the person who has asked a question, to come back to us, and we are very happy to give a more detailed insight. And I hope it answers the question.
Thank you, Eva. There is a question in the chat again. Can you explain briefly how you get phosphorus, which I guess how you monitor? Maybe the person who asked can clarify the question.
Yeah, sorry. It's Mikel. Yes, I was talking about phosphorus because I have seen in the chart when you choose chlorophyll, cyanobacteria, that there was also phosphorus. Is that right or not?
Okay, maybe. Okay, this is Vangelis Romas from Memphis. Maybe you are referring to the process-based water quality model that we are performing inside the reservoir. So this information does not come from the Earth observation. It is simulated with a water quality and eutrophication model by Deltares, coupled to the hydrodynamic model. So this information is simulated, available at every computational cell and at different depths inside the reservoir. And the same happens with other nutrients, nitrogen and suspended sediment and oxygen. These are non-optically parameters, but still with water quality modeling, we can quantify them and give information in a forecasting mode.
Okay, thank you. I understand that from historical values and the model, you have a good model, and then I understand that from the current images, you use that images to get current values, something like that in the model.
Yes, we have calibrated our models with historical datasets, including both Earth observation and in situ monitoring datasets. And then, yes, the model can provide information about nutrient. And one thing more I have to say is that phosphorus loads are also provided by the hydrological model in a catchment basin. So we are actually using this information provided by the hydrological model by HYPE to quantify the nutrient fluxes that enter in our reservoir. So phosphorus and generally nutrient quantities are available both from the hydrological model at the catchment level and from the water quality model inside the reservoir.
Okay, thank you. Very interesting.
Thank you. Eva, I have another question for you, which is how long does it take until a final product is available on the platform?
Yeah, very good question. Indeed, we are an operational service. So that means the moment when the satellite data itself is available, we start processing it with our automated processing chains and also the automated quality control. And you can expect to get the product in 1 to 3 hours after the satellite data was available. So really in near real time. And yeah, as we say, it's an operational processing chain.
Mm-hmm. Thank you for that. Evangelos, so I'll go back to you. So at which spatial resolutions you provide your hydrological and water quality forecasts?
Okay, yes, I will start with the hydrological model, which is performed at the catchment level. And we are using the European and the worldwide versions of the HYPE model. So what we have done in PrimeWater is that we have extracted those 4 case studies from these, let's say, continental setups, and we have downscaled them using a finer catchment delineation. So to give you some numbers, the worldwide HYPE setup uses an average catchment size of 1,000 square kilometers. While in PrimeWater, the US and the Australian case study are using an average catchment size of about 500 square kilometers, almost the half. And in the European case study in Sardinia, we can go even lower at 300 square kilometers. Now, regarding the the water quality model, which is performed inside the reservoir, we are using a much more smaller cell size, typically at 100 by 100 square meters, which of course depends on the shape and the size of the reservoir. So for more complex geometries or for reservoirs with a narrow shape, a river-like shape, we need to go to smaller cell sizes. If we have a very large water body, we need to go to higher cell sizes. So not to end up with an excessive number of cells, because this is always a matter of computational efficiency and modeling performance. And in the vertical layer, we are using layers with a thickness of about 5 meters. This thickness is variable, so we can allocate thinner layers at this part of the reservoir where we expect the thermocline to appear. So in this way, we are able to resolve stratification events in reservoirs without using too much number of layers, which can lead to excessive run times.
Perfect, thank you. We have time for another question, and just one, and it's what input is required to predict chlorophyll A concentrations with data-driven models? You can give an answer on that.
Okay, I think Kyriakos can answer this question. He will definitely give you more details than me.
Hi to everyone. Yes, well, the data-driven solutions that are available and provided in the platform are all driven by hydrometeorological, let's say, variables. So to be more precise, in all cases, or in every model, we are talking about hydrological inflows from upstream catchments, nutrient influxes, and weather data related, for example, to radiation, wind data, air temperature, precipitation, and so on. So there is a comprehensive, let's say, list of features that actually drive the model. Naturally, not all of them are always relevant for each case. So there is a whole pre-processing through which we're trying to select only those features that are meaningful and do not complicate the model, introducing uncertainty rather than accuracy. So from this, let's say, wider list of potential features, hydrological and meteorological, there is a subset of them that's actually we're actually taking into account. But this is initially, let's say, the what drives this type of models: hydrological inputs, nutrient influxes, and weather data.
Thank you, Kyriakos. Thank you, Evangelos, and thank you again, Eva. I think this concludes session 1. So we now go to a mini break of 5 minutes. So we can be back at 1:45. So in 5 minutes, please. Thank you all once again. And if you have any other question, please do write them in the chat, both for Eva or Evangelos. Thank you. See you back in 5. Okay, everyone. Thank you. I hope you're all back from the break. We'll now move to session 2, and I'll give the floor to Catherine Cross, who will moderate this session. So, Catherine, the floor is yours.
Thank you, Samuela. So I'm Catherine Cross. I'm working for IW as a consultant. I'm based in Bangkok, Thailand. So I'm just going to give a brief description of this session and how it's going to work. And then I'll also introduce the panelists that we will have that will take part in some of the discussion. So the purpose of this session, so it's going to be interactive, so we'd like you to take part, is to get your feedback and inputs on key components which will help PrimeWater provide Earth observation services to both aquaculture and the amenity and recreation sectors. So in the chat, there should be a link to an interactive tool called Group Map. You can either click on the link or you can use your mobile phone and enter the code. To access, you just need to enter an email address. So what we will do is we'll start with some questions to get an idea who is joining today, followed by 3 sets of questions, one on harmful algal bloom adaptation, secondly on parameters and indicators, and then thirdly, thresholds, and finally barriers. After each of these sets of questions, we'll have a short discussion, and I will like to introduce the panel that will be supporting this discussion. So maybe when I introduce each one of you, you could just turn your video camera on. So firstly, I'd like to introduce Mary Beth Neely. Dr. Neely serves as Geo Aquawatch Secretariat's Scientific Coordinator, and she's working for NOAA's Satellite Oceanography and Climatology Division. Mary Beth has a background in harmful algal blooms and coastal, estuarine, and riverine water quality monitoring, and she brings a wide variety of experience from field sampling and laboratory analysis to sense operation and maintenance, managing big data. So we're very happy to have her here today. The second person I'd like to introduce is Jennifer Doughton with the Southeast Coastal Ocean Observing Regional Association, of which she is the deputy director. So Jennifer is responsible for overseeing the development of SACURA's updated regional observing plan and managing data management and communications, and growing the observing system. She is also, with her husband Jay, owning and operating Carolina Mariculture, which is an oyster farm where they use off-bottom mariculture techniques to farm and raise oysters. So it's very exciting to get someone with hands-on practical experience. The third person I would like to introduce is Kirsten Stelzer. And Kirsten works for Brockman Consult since 2000 as a remote sensing specialist. And she's leading the geoinformation department. Her research and working fields are ocean color and lake water color, as well as intertidal, flat, and wetland remote sensing. And her work is interfacing scientific work and the design of user products for various applications and operational use. So very pertinent to the discussion today. And then last but not least, I would like to introduce Emily Smale. Emily has been serving as the Secretariat Director of Geo Blue Planet Initiative since 2015 and is a Senior Faculty Specialist at the NOAA University of Maryland Cooperative Institute for Climate and Satellites. Emily specializes in using science to support informed decision-making and the development of effective ocean conservation and development policies. So yes, I'd like to welcome all of them here today and look forward to the discussion. So before we get to that part, so I'd like to invite everybody to log into Group Map. Just for your information, so you know what we will do with the results from the discussion, is that we will provide a report within the next few weeks for your use and review. And it's also an opportunity, we'll provide opportunities for continued engagement beyond the workshop through PrimeWater as well as Aquawatch and IWA. So I'm going to take you to the Group Map, so logged in. So I'm going to take you to the first step, and you don't have to do anything. I'll bring everyone there. So firstly, we just would like to get an idea of what is your area of interest. Is your work in aquaculture or amenity and recreation sector, or somewhere or another area altogether? So if it's please just put your response there, and if you have another area that you're interested in or involved in, please just type it in the box here. So I'll just give you a few seconds. Okay, So we've got a split between a variety of different sectors, aquaculture, amenity, and recreation. Some people are involved in both. Some people are looking at specifically at water quality services, Earth observation water quality service. So we've got a variety of people who have joined today. Right. Okay. So now we know who's in the room. We have a set of questions, and I'll just increase the screen so you can see. So I'll just explain the questions, and then please go ahead and answer them. Well, you can go ahead and answer them whilst I'm speaking. So the first question is really for the aquaculture sector only. And it's asking, what is the most cost-efficient adaptation measure in securing aquaculture production in the case of a harmful algal bloom outbreak that can help with minimizing financial damage? So you can choose one or more of the options here. And if there's an option for other, and if you've answered other, just please provide that information. The next question is for both aquaculture and the recreation and amenity sector. So just that first question is focused on aquaculture. The other one is I guess for everyone. Other ones are for everyone. And this just asks basically to what extent will a 10-day forecast of key water quality parameters assist in both aquaculture and in amenity and recreation. So just put your indication from 1 to 5, 5 being it will assist greatly and 1 being not really at all. And then the questions after that are again for everyone in whatever sector you're in, asking how Earth observation can assist in various areas. So I imagine people have started answering them, but I'll just give you a couple of minutes to put your thoughts in. Yeah, these three last ones are focusing on regulatory compliance, sustainable production, which obviously is probably more focused on aquaculture, and then environmental protection. So if there are any questions that you don't feel relate to what you're doing, I mean, feel free to skip them. And regulatory compliance could be both from a health perspective and an environmental perspective as well.
Catherine, I do have a question on question 1.
Yes.
Can someone explain what they mean by premature fish stock collection?
I'm going to hand that to Apostolos. Could you provide an explanation there?
Hello, hi. Well, we actually put together there some list of possible options that we identify in prior, let's say, discussions with industry stakeholders. What these particularly means is that the way that people explain that to us is that sometimes decision has to be in order to actually take out fish stock before the maturity time has to be made in order to be in a more proactive way able to actually market, have a better market price to their stock instead of just leaving fish inside their cages to mature as they are planned, but be affected by off flavor, for example, compounds, and then experience a loss in price. So that was the context of this particular kind of measure in a way, a trade-off between gaining, let's say, in fish mass instead of selling fish earlier before time in order to gain in terms of value decrease due to a flavor compound.
Thank you, Apostolos. And Mary Beth, you had a comment on that as well of the interpretation.
Yes, I think based upon a recent panel that I participated or that I listened to, an aquaculture professional in Virginia said that he only harvests when there's an order for his shellfish. But if he knew that there was a reason to harvest early, because he tends to deliver the shellfish live, he might opt to harvest early to avoid a HAB and maybe, sell the oysters as the shucked product or for a price loss.
Yeah, no, I just, premature fish stock collection, if you have not larval, excuse me, but like, since we work in shellfish, but if we have like, juveniles, your spat, we can take them out of the water especially in the winter for a bit of time. So I just wasn't exactly sure what that stock collection meant. Like, was it moving that premature stock elsewhere, or did it mean something totally different? So I didn't want to select it not knowing exactly what it meant.
So I think you should still be able to enter your enter information, but I'm just showing the results. So I'm just looking at the answers that were provided for the first question on that was more focused on aquaculture. And I was wondering, Jennifer, just looking at those responses around cost-efficient adaptation, would you have anything to comment on that, or from your experience?
I will say a lot of this is, not a lot, but several of the answers are very fin fish production specific. So I think that might be why I'm not understanding all of these. And I work definitely in shellfish production. So, for us, we're like hold on, I've lost the answers. Anyway, so some of these, like incurring reduced fish prices due to off flavor compounds. I mean, we as shellfish could not harvest in a HAB bloom. I mean, we would be shut down for any harvest to start with. And that's in the US also. So some of these I think are kind of depending on where you are and what your rules and regulations are. And so it's a little tougher for me to comment on all of these.
Yeah, exactly. That's true. It does depend on where you are, I guess, in the world. And as you said, the legal context as well. So maybe just building off of that, we had some reflection on the usefulness of Earth observation I'll rephrase that question, the usefulness of a 10-day forecast of key water quality parameters for both aquaculture and for amenity and recreation. So I was wondering, maybe Kirsten, just from your experience, I mean, most people look at this being assisting significantly, but what have been some of the benefits and positive impacts from your experience?
So I would say especially this combination of modeling, saying forecasting and Earth observation brings here the benefit, because when using only Earth observation, you have the observation, but not the transition to the future. And in order to take actions, of course, it's best to know a bit in advance what might come to your stock. And therefore, this combination is really good, because the Earth observation brings perhaps a bit more reliability to the model result. And then you can, by assimilation, go then ahead with the modeling. And this is why the 10 days is quite, or perhaps even 3 days, so that you have something in the future that's quite valuable.
Yeah, and I imagine that also helps for planning and preparation. So Emily, do you have any comments on the results from this question?
I echo what Kirsten mentioned, that I think 10 days is a struggle, but that even 3 days is enough advance notice, and certainly within AquaWatch, and I believe I'm not speaking for Emily, but she can unmute and concur or disagree, but we definitely espouse the whole package of Earth observation, in situ observations, and modeling as the gold standard for that, because it's just a trust building exercise to have all of them.
Thanks. And, I build on that. When we do engagement, of course, the users always want as much lag time as they can get. But, you know, I think 10 days is certainly helpful. There have been some examples, I would say, off the coast of Chile. There have been a lot of, you know, salmon aquaculture people who are very interested in the HAB forecast. And they've had a lot of very significant losses in some of their salmon aquaculture due to harmful algal blooms. So having those forecasts have been, you know, very important for some of their fisheries there. So I think having these forecasts are really important. And as Mary Beth noted, incorporating it with models is really important. So having the combined data and information can be really useful, and as much information as we can get out there to users is important. And I think also trying to get data that is as regionally tuned as possible is also important as well. We've also seen cases where some users are using global data products that might not be appropriate for their location. So I think that that's something to take into consideration as well.
Great, thank you. And Jennifer, I was just wondering if you would be able to comment on that, and also from a practical point of view about like the reliability of forecasts in terms of production.
So for us, and again, not to keep harping on it since we're shellfish, you know, we run into problems in the shellfish aquaculture side because we are so near shore, right? We are, while we do off-bottom aquaculture, it's depending on the season, 3 feet of water to wintertime, 10 feet of water. So, you know, very shallow water. And we run into issues with low DO as well as extreme freshwater inputs at times. So shellfish water temperature is not as big of a concern, but dissolved oxygen is. And when we have large pushes of fresh water that are coming through, you know, having some forecast of that would really help us, because if we know conditions are going to deteriorate, we can do a big harvest all at one time and sell off stock, get them out of the water, get them out of the production. When we don't have any forecast and we're kind of just taking things as they come, then we actually can lose money because, you know, hey, if we had advance notice, we could have actually sold this product, but now I'm sitting on this product because water conditions don't allow me to actually harvest anything.
Yeah, I imagine it's a fine balance.
It is.
So just looking at the next 3 questions, because we've got about a minute before we move to the next section. So these questions we're looking at how Earth observation can assist in regulatory compliance. So I hope you could see the results there. But perhaps maybe starting with Kirsten, if you could perhaps comment on what do you think are the benefits and positive impacts of Earth observation technologies across these areas? Oh, you're
yeah. Especially for the regulations. So it is always a combination of monitoring systems that are already in place and taking Earth observation as additional information and perhaps optimizing the existing monitoring programs. Because Earth observation tells you where your in situ measurements should be taken, when they should be taken. And so it's again a combination of different techniques, and here Earth observation for sure can be very big benefit, but not alone. Combination again is the key, I would say.
And Mary Beth, would you like to comment on that as well?
Sure. I actually said that this would have, I think I was one of the 2 votes. And that's just because, you know, I wasn't looking at it from the perspective that Kirsten just brought up, which is actually optimizing a regulatory compliance sampling strategy. However, from at least in the U.S., Earth observation is useful as an early warning system for when to shut down shellfishing industry and you know, when to start satellite sampling. But unfortunately, we do not that does not meet the regulatory burden in the US. They still have to do lab-based analysis of shellfish meats before any sort of regulatory action, either banning sales or lifting the ban on sales happens. So that's why I ranked it a 2.
Okay, great. I'd like to continue this part, but I think we're going to need to move on to the next section. So I'm just going to give a bit of background from PrimeWater. I hope you can see my screen. So in the next section, we're going to talk very briefly about parameters and indicators for harmful algal blooms. To give you some context on what PrimeWater is focusing on, so looking at the different stages of forecasting and early warning. So obviously the most commonly used are nowcast-based early warning, which uses grab samples and lab analysis, and the results are algal alerts as they're happening. And then PrimeWater, as you've heard, is exploring the use of deterministic forecasting based early warning, which can provide information on the magnitude, when and where the hazard may occur, as well as probabilistic forecasting based early warning, which also includes the probability of the hazard occurring. And then finally, something we probably won't get so much time to touch on today is impact-based early warning. So all of these provide forecasts up to 10 days in advance, but with the impact-based early warning, it's on the expected impact of the forecasted water quality hazards, such as population affected or loss in fish productivity. So we're going to do another group map. So perhaps one of my colleagues could put the link in the chat. Again, it's the same link, but I'm going to bring everyone to where we have to go. So what we would like you to do, and hopefully you're here and on your computer or on your phone, is so the first question shows a list of possible forecasted parameters and indices that could be used as proxy indicators when describing phytoplankton outbreaks or harmful algal blooms, and such as chlorophyll. So we'll just give you a minute if you want to add any additional parameters that you would use or that are missing. So in order to do that, you just click and you on the plus sign and you just type in there. So I'm going to move us to the next step. So what we would like you to do here is to prioritize these parameters and indicators in descending order. So putting the highest priority at the top. And to do this, you just drag and drop over here. And you don't need to drag over all the parameters. So just whichever ones that you see are relevant to your work. So you just put them in descending order, and I'll just give you a couple of minutes to do that. Okay, just a few more seconds. I'd also like to mention, if anyone has any questions at any time, please just put them in the chat, or you can just use the raise hand feature and turn your video on, and so that it comes to my attention. So please go ahead and do that. And if you do have a question, just if you can state your name and your organization. There's a question on how to drag on a mobile device. I haven't actually tried it on a mobile, so we will look into that. If you aren't able to do it, you can also put it in the chats, or this will be up for a while, so you can also do it later. Okay, I'm going to bring everyone to the results step. So this is, unsurprisingly, chlorophyll is at the top. I think we'll come back to this and for discussion, but before we go there, we'd just like you to do one more exercise, which is on thresholds. So here, for the top two parameters, just the top two parameters that you chose, that you prioritize, sorry, we'd like you to provide the thresholds based on specific best practices or industry standards that you follow. It doesn't have to be the actual numerical value, but also, what does your industry consider in terms of thresholds, or what are you doing in terms of thresholds? What thresholds do you have to follow? So yeah, perhaps I can just kick off a short discussion here. So maybe starting with Emily, perhaps you could reflect on this list, and maybe also any thoughts on like what are some advantages of some parameters or indicators over others in your work?
Thank you. So I mean, I know that chlorophyll is a very popular indicator. In terms of ease of monitoring, chlorophyll is available from satellites as well as, you know, in situ fluorometers and things of that sort. So it's a, you know, easy collection for looking at monitoring. So it's a, you know, very popular indicator from the Earth observation standpoint. So it's something that's used pretty often for initial detection of phytoplankton outbreaks. So I think that that's one of the reasons that it's marked as being very popular, because it's a way to do an initial detection. Obviously, if you want to get more in-depth information, then looking at what type of bloom, you know, so particularly if you're looking at if it's a harmful algal bloom, then you want to know what species is causing the bloom. So I think that that is an indication for what is the phytoplankton species. So that's why it's ranked as number 2. So I think that that has a lot to do with some of the other information. And then obviously looking further down at information about, you know, the stratification and water temperatures, looking at then if you're going to start getting you know, dead zones that are going to impact your aquaculture facilities and your species that you have in your facility, and what's driving that with your nutrients. So that would be my interpretation of the rankings.
Great, thank you for that. And it would be good to also hear from Kirsten your reflections, and also yeah, the same question, what do you see as some advantages of it, some indicators over others?
I don't know if I can add much. So as she said, it's a chlorophyll that is easy to get, and therefore it's good that we have it in different techniques, although different techniques bring different results, might bring different results. But without the species composition or an indicator, if there's a harmful algae species or outbreak, yeah, this information is less. So this, in addition, is a very good information we need to really assess the situation.
Okay, great, thanks. And Jennifer, do you have any thoughts or comments? Oh, sorry, we have to unmute you.
Sorry, I was muted. No, I don't really have anything else to add either. I will say though, on the, if we use this again, we need to make sure that you also have the ocean side, because I was a little uncertain about what to do for everything listed as catchment and reservoir, because we do work mostly on the ocean side. So I kind of left those blank. Yeah,
fair enough. Yes, I was reflecting on that actually at the beginning. We didn't really, the focus is probably a bit more on freshwater, but obviously in this discussion, there's a strong focus on coastal waters as well. Mary Beth, did you want to add anything?
Only that I ranked, I was again looking through the lens of management action. And so I ranked dissolved oxygen fairly high, because some mitigation techniques can be applied in certain areas of certain water bodies, you know, introducing a bubbler if dissolved oxygen plummets. But I do like that phytoplankton species was ranked very high, because of course, you know, the application of the term harmful algal bloom is sometimes a struggle, because many people rejoice when there's an algae bloom, as long as it's the right species. And it can definitely contribute to aquaculture and not harm recreation or public health. if they are non-toxic species, of course, until you reach the point where sheer biomass is pulling down the dissolved oxygen, and then it's a problem from an aquaculture perspective and fisheries perspective. But yes, that would be my only comment.
Okay, yeah, good to have that reflection. Okay, so just looking at time, I think we're going to move to the last exercise, which is on barriers. So this is again another group map. I don't know if we've solved the problem of dragging, but I'll keep on it. So here, what we have is a list of barriers to water quality forecasting and warning. So there's a list of barriers that have been provided already, but if you have any additional ones that you think are relevant to putting in place water quality forecasting and monitoring and warning, then please add those, both from a freshwater and also coastal water perspective as well. So I'll just give you a minute to do that. So it's the same, if you've gone out of group map, it's the same link that you used before. So I see a couple of additions on the short pollution events, the formats of the forecast matters a lot, knowledge transfer. Okay, so we'll just move to the next, next item. So here, again, it's the same before and as before, and you just drag and drop the barriers descending from greatest to least in descending order. So I guess greatest barrier to one that's not such a great barrier. They're probably all barriers to varying degrees. So you can just pick it up and drag it over. And I'm also on my mobile device, so I'm going to look into how to do it there. So I'll just give you a couple of minutes to do that. And again, you don't have to drag them all over, just which ones you think are relevant. All right, so I'm just bringing you to the results, which if you're on the phone, you should also be able to see, and on your computer, and also on my screen that I'm sharing. So we actually did this exercise a few days ago, and I note that we have the same top barrier, which is lack of data or monitoring of water quality parameters. Yeah, then I'm just looking at the other one, the relevance of warnings to stakeholder activities, reliability of forecasts, and going down the list there. Yeah, so it'd be good to hear from our panelists on, I guess, reflecting on this list, but then also from your experience in your work, what are some of the main barriers, and how are you addressing them, or how are your colleagues addressing them? So perhaps we can start with Emily again.
Sure, Catherine. So I think, one of the challenges with lack of data is a lot of the, for the coastal areas, a lot of the aquaculture facilities are really close to the coast, and a lot of the satellite data particularly is, very lacking or not that accurate really close to the coast. So I will say that there are a lot of new missions that are going to be coming out that will help improve that. So that will be promising. So I think that there will be more data products coming out in the future that will help with some of that data information. There also are data available in some regions that just are difficult to access. So they might be in state repositories or other academic institutes that just aren't shared very well. So I think that that's something that needs to be improved. It's just the data sharing and availability. Making it clear that this data can be used by industry and not just the academic and government communities. So I think that that's something that as a community we could work together to help improve. Relevance to warnings, again, doing engagement with the stakeholders to make sure that any products that are being produced are being done in collaboration with aquaculture facilities, so that they are, useful. I think that in general is something that we found with development of products, is that you have to engage with the end users pretty early to make sure that you're actually producing warnings and products that are going to be useful for the end users, and making sure that you continue to engage with them to make sure that it's tailored. Also, if you have a really good product in one region, doing that knowledge transfer to see if you can produce a similar product for a different aquaculture facility that might be in a different area of the country, region, or world, is something that I think we could work together as a community to help build up that capacity. Short-term pollution events are hard. I think sometimes, especially with the Earth observation data, so the revisit times, especially for the high resolution data, are not that frequent, so you can miss a lot of the short-term pollution events. So for that, a lot of times you have to have different types of alerts. You might need to rely on maybe in some of the in situ datas, or stationary platforms, or have sensors on your aquaculture pens to help detect some short-term pollution events, because you might miss that with satellite data just based on the revisit time. So I think that's something that might have to look at in a different way. Also just making sure that there are, I think the investments, bringing up the Chilean example again, a lot of the aquaculture facilities there got together and funded the products themselves. So it's more industry driven, and they funded a lot of the researchers to develop these products. Looking at it in that way versus always having the government fund it, I think that that's something else that needs to be considered, is different ways of funding. If you need it for your business, then you might need to look at investing it. Maybe you need to get together with the local aquaculture facilities in your area and maybe pool some funding to get some group resources to work with scientists to get alerts for your facilities, with the understanding that it could benefit you financially. But I think that there are a lot of new technologies that are coming out, both for the in situ monitoring and for the remote sensing, that are really going to help improve products.
Great, thank you very much. That was it was good to get your insights. I definitely on the data sharing. I'm based in the Mekong, and this is a constant problem across the basin and between countries, also with the South China Sea as well. So maybe I'll just pass to, Kirsten, perhaps if you have any comments on this. We've got to wrap up in a couple of minutes. So maybe Kirsten, if you have any comments, and Jennifer and Mary Beth as well.
Yes, a short one. So I think this point, preference on maintain existing practices. So this is really a development of the past years that this has changed. So 10 years ago, it was really so difficult to bring Earth observation into practice. But meanwhile, it's really an accepted method. And so this point is going low. I mean, it's ranked low. And I would say some years ago, it would have been ranked higher. And I'm very happy about this development, that Earth observation really is coming more and more into practice and is accepted. And then for the user designed alerts, I would underline this, that this is so important that you develop something that the user can use immediately as he needs it. And this might be especially for this user, and for another user, it's something else that is needed. So also good working area there.
Yeah, in a previous session, one of the speakers said that Earth observation, the use of Earth observation services will become it's sort of like an evolution, like mobile phones, that it's becoming more and more accepted. So before we wrap up, maybe Jennifer and Mary Beth, do you have anything to add to barriers and how they can be overcome?
Not really, but just to add on to what was already said, I guess. On the format of the warning or forecast, I definitely have that one ranked higher, mainly because, at least in the southeastern United States, when we have a broad range of aquaculture and recreational activities, a lot of the same information is relevant to both groups. Therefore, you have to figure out how do you target those groups and how do you make that information accessible to them in a format that they will look at. So it's not only just, hey, we have this great information that we can now share, but people want it in different ways. So how do we push it out to them in ways that they will use? And what we're seeing a lot is that people do like it pushed, and they like apps, not websites. They want anything that's mobile friendly, that if they're going to the beach today on the fly, they can find out if there's a bacterial warning for the beach. Because in the US, we are seeing that happen a lot more frequently, especially in the Southeast, is high bacterial loads at beaches.
Yeah, and I guess having easy access to that information is key.
It's key. Mm-hmm.
Yeah. Mary Beth, did you have any final thoughts or words?
I did not. I concur with all the other panelists. They did a great job of covering my points. Yeah,
great. Well, I'm going to have to wrap up. It was quite rapid but very interesting discussion. It would be great to have more time. I'd like to thank all the panelists for your time today and your inputs, as well as the everyone else for providing your inputs into the group map. As I said, we'll compile this information and share it with you after the workshop.
Thank you, Catherine. I think we can now go for a small break. So once again, 5 minutes break, and then we will be back with the session 3. Thank you all. See you in 5. Okay, everyone, welcome back. This is session 3, user preferences for Earth observation services. I'll give the floor to Nikos, who will guide us through the survey. So Nikos, the floor is yours.
Thank you very much, Samuela. So PrimeWater, among its objectives, has the aim to study user preferences for Earth observation services. This work is undertaken by Burgundy School of Business, myself, and my colleague Lara Agnoli. So I will try to explain a little bit our approach and help you, encourage you, or promote your replies to this survey, which helps us very much accomplish our objectives. So our objectives, our objectives is to study the attitudes towards satellite-derived water quality products, identify obstacles in adopting satellite-derived water quality products, and the drivers. So we expect from this to learn some things which are very, very important on how to create sufficient or efficient bundles of characteristics to conform these products. So to start with, before I tell you some more information on specific questions that look a bit different from the ones you answer usually, I would like you to go to this survey. Probably you will have soon the link on the chat, and go on completing with this general information. It's still anonymous, but you contribute with your information, and you stop please at the question, how many years do you work on your organization or corporation? So you do the questions until you complete how long have you been working for this business dash organization. In the next part, rather than talking about Earth observation services, let's talk about wine. So I will illustrate a little bit better the type of task, the type of question you will be asked to complete. So imagine that you have 4 bottles of wine, 1, 2, 3, and 4. You have some information on the labels, wine from autochthonous varieties, vineyards are volcanic soil, respect local traditions in winemaking process, Sol family winemakers since 1792. And then you have the prices, 13.90, 8.90, 18.90, 23.90. So you will find a link on the chat, and you will have to make your choice of wine with this information.
Okay.
Yeah, so obviously you didn't have the opportunity to taste the wine, but you had some information, you used this information, and you made your choices. And so results of the study is that you, of course, took the price into account, label style, the logos, and back label information. So these are the drivers. So how does this relate to our study? So in our study, we will give you options for 2 types of products, for monitoring and forecasting services. So here you have 3 options of monitoring services. So imagine that you are given option 1, option 2, option 3. They have different image resolutions. 2 of them are similar, but the third is different. Then you have the offered Earth observation-based water quality parameter, and you have 3 different parameters. You have offered parameter representation. So you have all pixel values in the reservoir at native resolution or aggregated reservoir statistics. And then you have the offered frequency. Is it 2 to 3 samples per week, like in 2 of these options, or 1 sample per week? And then the estimated price per sample in euros and US dollars. And you have 3 options, option 1, option 2, option 3, and of course you have the option none of them. So for us, it's important that you make this choice, and then you have a different kind of products, which is forecasting services. And in forecasting services, imagine that you have this kind of product configurations, option 1, 2, and 3. In 1, we have the model parameter is different, in 2 and in 3 as well. You have forecast horizon, subdaily or 1 month ahead, temporal and spatial resolution, daily values at river level, and then you have a estimated price of forecasting services per year. And again, you have prices in euros and US dollars. And you again have option 1, 2, 3, or none of them. So for us, it's very important that you make this kind of choices for 2 reasons. One is more or less obvious, is we want to know your choices in these among these hypothetical configurations of the product, but we also make more inference about how these choices relate to your other characteristics and your other responses. So now imagine that you are asked to rate your level of agreement with the following statements. This is a type of question that ranks your own perception of how much each statement is correct. So as you see, as you reply, things are aggregated, and we will have this information. But this information in aggregate, it's useful, but it's even more useful in association with your choices. This is why it's so important to associate, to have the complete survey with all your choices and all your statements, because this is going to help us create a model like this. So can we go to the next? Once we have all this information, we are not only interested, and this is just also an interest, but not a primary one, in your choices of these products, but by your choices, we can associate your attitudes and some agreement with some subjective norms, how these affect your intention and how your intention affects your hypothetical behavior. And from this, we can infer not only your choices, but also what is the weight of all these aspects in your choice. And this way we could design better offerings for Earth observation services. So we would be able to see that, for example, someone is putting a lot of weight on one characteristic compared to another, and this then would become more important in the configuration of the offerings of the products that would be available or should be available. And then you will have questions about familiarity, about trust, about attitudes, and knowledge. So these are going to be your data, and which is collected anonymously. And once you go to the end and you complete the survey, which is very important for us, and incomplete surveys are not useful, but once you complete it, also you receive a 10% discount on a membership to International Water Association. And of course, you receive our sincere thanks for contributing to our survey and to our approach to understanding better the value of these products, not as products as such, but even on hypothetical future offerings and configurations.
Thank you, Nikos.
Thank you very much.
So I'll now leave the floor to Apostolis for some concluding remarks. But before that, I just wanted to stress out, if you can please keep your browser with the survey on, and after we conclude the session, do take 10 minutes to reach the end of the survey, because as Nikos was saying, incomplete survey, we cannot use them. So we really need you to go until the end. And there is this little gift for you, about 10% discount to IWA membership, to show how grateful we are for those completed survey. So once again, thank you all, and I'll leave the floor to Apostolis for some concluding remarks on the session and maybe the entire week.
Thank you, Samuela. Thanks all to. I'd like to thank all the panelists today for today's workshop, but also all the panelists that shared their insights and thoughts throughout this week. But above all, I'd like to also thank the attendees in this workshop. It was a very interesting, it's always interesting discussing with stakeholders and water professionals from those kind of aspects. PrimeWater is about that. I mean, PrimeWater is a research innovation project, but at the end of the day, what aspires and to do, and what is the ultimate goal, is to actually bring the science closer to the expectations and the needs of the actual end users, of the actual water professionals. And we truly value all those opportunities that we're having in engaging in communication. Different angles, different insights are very, very much appreciated. And what we will try to do at the end of the day is to synthesize, to generate an overview of those aspects that we're discussing today, and we have discussed also the last few days. Trying to just to pick up a few points from our discussion concluding today, as a concluding remarks. I'd like to mostly say that technologies, advanced technologies that rely on Earth observations are becoming more and more, let's say, easy and closer to end users. They're become more familiar to the users, and this is a good thing. There are opportunities for those technologies to contribute. Either this is so-called regulatory compliance, or even in operational aspects within the sectors themselves, directly as a monitoring applications, as monitoring tools, or in combination, as very well described, with all the other techniques. And I think this is the key word: combining technologies together in order to actually reach to the required end result. So Earth observations can work in a complementary way with modeling tools, with hydrological modeling tools, and generate forecasts with lab analysis, with in situ measurements, with other technologies, and at the end of the day, provide a strong decision, a basis for good decision making in the industry. So I think this is the important one key important thing that I believe came out clear from our discussion. There is an extra mile to go when it comes to operational services, and for example, aquaculture, the large level of variability of practices implemented on the ground, and that depends on the actual production units or techniques applied in the production. So obviously need to be researched. This information needs to be translated so as to fit the purpose of these particular, let's say, practices and requirements. So that takes us to the let's say, possible barriers or constraints that we have very, very briefly touched upon. I see here in my notes that lack of data was ranking on the top of this list, and there was a good discussion around that. Data, there are technical difficulties about having fairly large number of robust data sets. Some of them are related also with the fact that the particular operations that we're discussing are actually happening on shallow waters, and then their observations still need to come up with more innovation, recurring time, so many technical, let's say, aspects that contribute to that. But on the other side, also sharing existing data. This is something that can provide a plausible answer to this, let's say, barrier. Nevertheless, combining again with other existing data is the solution. But then a very important aspect again on the barrier side is the translation, is the transformation of information in a way that is appreciated, is expected in the best possible way, but the people that this information is actually produced for. And then obviously reliability is a key, is a central aspect of the data, either monitoring or forecasted. And this is where PrimeWater is putting a lot of emphasis. Main focus on PrimeWater is on the scientific components of these technologies, running cross-cutting research among different scientific domains like remote sensing and hydrological modeling and ICT, exactly to add into the reliability of the end solutions. So with all that, I'd like to thank you again for sharing your insights on the sector with us in this today's workshop. Thank you all so much. Samuela, the floor is yours.
Thank you, Apostoli. I have a couple of notes to add. I put some links in the chat. So you will receive the, you can access our website where you can see the presentations and the recording, which we will also be post on our PrimeWater YouTube channel. And I'll invite you to fill the survey and complete your and show your interest to join the IWA Earth Observation for Water Management Community of Practice, which is the platform where we'll continue the discussion. You will receive all of this also via email, so please look out for that. And I think with that, we can conclude the session. Once again, thank you to our panelists, thank you to our moderators, and thank you all for attending and for your valuable contribution. So I wish you a nice rest of the day and a good weekend. So thank you, everyone. Bye.
Thank you. Bye.
Bye.
Thank you. Thank you, everybody. Bye-bye.
Bye-bye.
Many greetings. Happy weekend.
And to you. Bye.
Bye-bye.